Welcome to this explainer. Today, we are diving right into an absolutely fascinating intersection of modern Python machine learning and historic clinical data. We're going to walk through a really cool DataQuest project that shows exactly how data science can take raw, old-school medical records and transform them into practical and honestly potentially life-saving predictive models. So, that brings us to a pretty provocative question. Can we actually use Python to predict heart disease based on medical data that's decades old? I know, it sounds a little bit ambitious, right? But this is a very real supervised machine learning workflow. As you'll see, specific patient metrics collected years and years ago can actually train an algorithm to flag health risks for future patients. It's like having a digital crystal ball, but powered by hard data. Okay, here is our quick roadmap for today. We'll start with the Healthcare Data Challenge, jump into the historic UCI dataset, decode those medical features, prepare our patient data, build the actual predictive model, and then wrap up with how this all advances your data career. Let's get to it.
Section 1. The Healthcare Data Challenge.
We're going to begin by casting you right into the role of a healthcare data scientist. Imagine this. You've just been hired at a healthcare solutions company, and they hand you a data set totally full of anonymized patient records. Your objective? It's highly practical. Your mission is to build a reliable model that predicts the likelihood of a patient developing heart disease. This isn't just theory. This is exactly the kind of high-impact, real-world problem that modern data professionals are hired to solve every single day. Moving right along to Section 2, the historic UCI dataset. Now, before we write a single line of code, we really need to understand our raw materials, and that takes us over to the UCI machine learning repository. Look at this number on the screen, 1988. Over 30 years ago, doctors compiled this foundational database of 303 patients from 4 different global locations. And it's the specific Cleveland database from this collection that has essentially become the absolute gold standard for machine learning researchers worldwide. But here's where things get interesting. While the raw dataset originally contained a massive 76 attributes for every single patient, experiments over the years have actually zeroed in on a process subset of just 14 critical features. This teaches us a really fundamental lesson in data science, More data isn't always better. By stripping away all that extra noise, researchers found they could build a much more accurate predictive model. All right, Section 3, decoding the medical features. Knowing the actual clinical context is really what separates a novice coder from a truly insightful data scientist. When you first look at the raw data set, you just see these intimidating abbreviations. But honestly, it's just human physiology. We translate jargon like trestbps simply into resting blood pressure and thalaksh into maximum heart rate. We've also got integers for age and serum cholesterol. Really getting a feel for these variables gives us the intuition about how our model is actually going to learn. But the absolutely crucial point here is our target variable. It's called num. This is the whole shebang. It's what our model will ultimately try to predict. In the original data, num ranges from 0 to 4. A 0 means less than a 50% narrowing of major blood vessels, essentially no heart disease. Values 1 through 4 indicate varying severities. For this project, though, we're tackling a classic binary classification problem. We just want our algorithm to successfully separate the zeros from, well, everything else.
Section 4, Preparing the Patient Data. So, now that we fully understand the clinical parameters, it's time to roll up our sleeves and pop open our Jupyter notebooks for the first half of this DataQuest guided project. As these first 5 steps show, a massive part of a data scientist's job involves using pandas to explore, visualize, and clean the data way before any modeling actually happens. You're handling missing values, running descriptive stats to hunt down outliers, and generating visualizations. You're essentially interrogating the data to figure out which features have the absolute strongest predictive power.
Which brings us to Section 5, building the predictive model. With our raw data beautifully prepped and our features selected, we finally transition into the core machine learning phase. Steps 6 through 10 walk us right through the actual supervised workflow. We build an initial classifier, and then we refine it. Step 8, hyperparameter tuning, is critical. That's where we're basically tweaking the internal dials of our algorithm to maximize its accuracy. Then, we rigorously evaluate our model on a separate test set of data it is literally never seen before, just to ensure it's actually going to work out in the real world. Specifically, we're using a k-nearest neighbors, or KNN, classifier. And it's actually super intuitive. Think of it like this. If a new patient comes into the hospital, the KNN algorithm looks at their blood pressure, age, and cholesterol, and it finds the K number of patients in our 1988 dataset who have the most similar stats. If the majority of those nearest historical neighbors had heart disease, the model naturally predicts the new patient is at high risk too. Makes sense, right?
Finally, Section 6, Advancing Your Data Career.
Let's just step back for a second and look at how completing a rigorous project like this translates into real professional growth. By bridging historical data with modern code, you're gaining seriously job-ready skills. DataQuest's whole philosophy is project-first learning. So instead of just passively watching tutorials, you're actively mastering pandas, applying supervised machine learning, and establishing an end-to-end workflow. You literally walk away with a verified project for your portfolio that proves to employers you can turn messy data into real predictive insights. Actually, I absolutely love this quote from Victoria Guzik because it hits the nail on the head. She said, "The projects on DataQuest were key to getting my job. I doubled my income." It just proves that hands-on, challenging projects are exactly what potential employers are hunting for. Moving away from simple fill-in-the-blank platforms and wrestling with real end-to-end projects is a total game changer.
So, armed with 1988's clinical data and today's cutting-edge Python capabilities, the only question left to ask yourself is, are you ready to start coding? The tools to predict the future are literally waiting right there in the data of the past. Will you be the one to uncover them? Thanks for joining me on this explainer, and I really hope this inspires you to dive into the data and build your own predictive models.